I'm gonna wait to see if it's streaming. I'm already tired, so I'm not sure how long I'm gonna stay here. Yeah. I think I'll put the timer for 1 hour and then I'll think about it later after this runs off or finishes. I figured out what was wrong here. It was because I wasn't returning. Now it seems to be working. So it returns 1 when it's inside and 0 when it's not. And I'm thinking about putting another variable here and calling it weight, and then increasing the weight by 1, I think, and then returning the weight instead. So I think that's what I'm gonna do. So weight. Because that way I'm gonna be able to get a gradient of how fast the points deviate for to infinity, or if they don't deviate at all, then that means they are inside. So I think that in the boundary is gonna give me a better visualization of all the points. And now after this, I think I have to change when I call the function. So the weight, or maybe I'll do, because the thing that I was thinking about is that it has to be proportionate to the uh, max iterations. So I guess I'll do weight equals to max iter divided 1 divided by max iter. That's a good approximation. But then that would be the opposite, I think. Let me think. It starts at, but then increase by 1 each time. I think ideally it would be from 0 to 1. So how can I do that? So max iteration is 100%. I think here I will start at 0 probably, and then I increase by 1 divided by max iteration. Yeah, probably this is fine. And then I have to think about how I'm gonna get this matrix and create a graph with the matrix. Now that's not what I want to do, but I want to visualize. So I think I'm going to use matplotlib to do that because I want to visualize in the grid, and I'm not going to use network X, as I don't think it makes sense to use network X for this. And yeah, maybe, so I'm going to search for this. I think I'm going to put some music for myself while I do this stuff. I think that visualizing the matrix is going to allow me to see if what I'm doing makes sense or not. And that's why I think it's a good idea. Then I think the next step is to study the geometric deep learning library. Because once I have the matrix with all the numbers, is the matrix is gonna represent then the oh maybe actually before that I should see the solutions for the number of islands. It changes here. And so what would be the difference between using number of islands and using a neural network? That's the question, I think. And studying that's gonna be allow me to understand more how the deep network works. I think the difference is that once you have the model, you can extrapolate, but and this problem is to count the number of islands, so it's slightly different. Yeah, I guess that's the difference, is because if I use this one, then it's pretty much counting all the islands and not finding the boundary. And then applying the machine learning model is to find the boundary through gradient descent or whatever method. So essentially, I think what I'm doing is pretty much uh, creating the geometry of the neural network, the weights. I'm fitting the fractal as the weights for the neural network, and then I have to think about if it's possible to extrapolate that into multiple different fractals, and think about how if it's possible to get the bridge between something that is tangible. Maybe I can use data, and then yeah, from that point I think it can get really interesting or it can go nowhere. So oh, I guess the guy does it here. I should just copy this thing. It's easier. Don't understand what this means, but I'm gonna put it there anywhere. Stands -1, sure. I don't know if I'm supposed to do something else here. Remember that it is different on Matplotlib, depending on whether or not you're using Jupyter or using an ID. So I might have to do something here. Yeah, but it looks like it's working. Obviously, I'm also gonna manipulate the variables. And first I have to see if it is working or if what I did doesn't make sense. But then if it makes sense, I can manipulate the variables, the weights and the size of the range and the size of the matrix. And I think, yeah, that's what I was talking about. I'm gonna do multiple different sets, multiple different matrices, and I'm gonna create a data set of these matrices. And then with these data sets, I can see if I can start studying the geometric deep learning to see if I'm able to capture the fractal pattern. There's still the question, I guess it's with everything of overfitting or underfitting. Because the question is, how do you find, yeah, how do you train a machine learning model to fit a fractal pattern without knowing what the pattern is? Let's, for example, let's say for example, the first surfaces of the skin, like the fractal pattern of a human being or something like that. Because the equation for that is not known. So that's why it's difficult. And it might be the case that it gets too complex, I think. Yeah, but that's the point of what I'm doing, I think. Because the level of complexity can be reduced based on the fractal patterns. If we're able to capture the fractal pattern instead of looking, because if we're trying to fit the machine learning model to fit the boundary, I don't think that works. But if we're able to train it so that it understands the fractal pattern, then I think it increases. There might be something there. I think that's what I'm trying to do. So instead of, I'm gonna try to think about a way to train the model without not trying to not make it fit the boundary itself, but trying to capture the fractal itself. That's the goal, I think. But it's gonna be very hard because I think the way that it's gonna work, if I use the libraries and if I just try to fit the data sets, it's just gonna use stochastic gradient descent and then it's just gonna fit the boundary. And that's the problem. There's must be a relationship there. I'm gonna practice typing while this runs. Maybe there's a different way to think about it as well. Because what I can do is create multiple different fractals and then train the models to fit the fractals, the closest approximation of the boundaries, and then try to see, try to get real data sets from different places, and then see how good the model predicts the data set. And then what I can do is merge the data with the fractals. So create a space of multifractals and then create a bunch of different models that have these multifractals and then apply them to the data and then combine them and see, and then potentially can create different fractals based on that, on the degree of confidence of them. Yeah, that might be a good idea. So you create multiple different fractals, then you plot the data, and then you see which ones have highest degree of convergence, let's say. And obviously that's still susceptible for overfitting or underfitting because it doesn't matter. But that's a problem with the paradigm of scientific paradigm. So there's nothing you can do about it. Because everything you know can always be wrong. Because it's based on your experience. And statistics is an illusion to some degree. And obviously, there's more ways to complicate this by increasing the number of dimensions and adding other physical concepts to embed in the matrix. So to run the calculation of what each cell is going to be, I can also do something with gravity or other laws of physics, maybe all the laws of physics. think I'm gonna study the library, the geometric deep learning library, or this one. Uh, I don't think I'm gonna end up using number of islands solution. I'm gonna close this. I think I have here as well. Yeah. What? I think I also have to reinstall Torch because I changed the environment. Because I remember installing a Torch before, but it looks like here is not working. And this also is saying that it doesn't have figure. So maybe he used a different thing there. The T figure. Hmm. Probably gonna put 50 here so goes faster. I'm gonna wait for this and then I'll run again. I think the best way is reading the documentation first, because first I have to become familiar with what functions I'm gonna use, and then after I have some experience, then I can go through the source code to understand how they are being, what's the logic behind and the software design behind the network. Hmm. Maybe this is not the best model as well, or the best library to choose for what I want to do. Because it might accept only a graph and not train with. Maybe I'm looking more for a classification type of neural network. Yeah. 'Cause essentially what I'm doing is just feeding, creating a neural network with the weights as a fractal. And then I want to compare that with real data after training on a bunch of different fractals. I just realized that I'm gonna change this thing here because I don't want to print a bunch of stuff. I'm gonna stop this. And then I'm gonna print the counts, which I was gonna do, but it ended up not doing. Maybe it's better to just do this. Trying to think if there's a way, because maybe what I can do is use the data instead. Create a x and y coordinates or a matrix with data, and then use the data instead to try to create the fractal from the data. Maybe that's better than what I'm doing. Oh, so it does work. Nice. Am I doing the right thing? Oh, it's because it's showing the wrong extent here. That's Yeah, I didn't know that's what it's showing here. It's minus 2 for 1, and the other minus 1 to 1. Search 1. Yeah, that's imaginary. The imaginary is the second one. This is y, this is x. So this would be the range here. Yeah, both of them are actually like this. So they're equal to this thing here. Yeah, so what I can do as well is, so I know that I think it's from the range is from 2, so I think I'm gonna try to get something that is like 2.5, or maybe minus 0.5 to 1.5. But I think that's gonna be inside of the thing. Yeah, I wanna see if I can capture right at the boundary, just see if I'm doing the correct thing. But it looks like it's correct. I wanna see if I can get captured right in the boundary. I think the approach that I'm taking is probably not gonna go anywhere. I have to think about something better to do. Maybe. I think it's worth exploring though and seeing what happens. Probably gonna learn a lot. I think that's where I got the stuff that I have there on the file. Hmm. Yeah, so it kind of worked, but yeah, what I can do is decrease the resolution. That's the thing. That's how I go deeper. But that can be a problem as well. Hmm. And it's good that it works though. I'm happy about that. I'm trying to think what I can do to go just zoom in inside the fractal. Oh, I guess I can use a narrow range, and that's one thing. And I think that changing this 2000 here is not gonna change much. Just gonna change the accuracy. So I'll try to reduce this by half, and I'm gonna put this. Let's see. Torch geometric. So yeah, maybe I don't have it installed. That should be the case because it's supposed to be on this file. Hmm. Yeah, so it's still not what I wanted though. That's the problem. Because I wanna dive deep inside of the boundary here. I guess I have to reduce even more the range. It's really small. Let's see if I go from 0 point minus shoot to 0 0.1. It might be a problem as well that I have to use a special library to deal with small numbers because of the multiplications. But let's try this 7. I should explain the thing here, the arguments. Oh, I should have installed this before running. Let me open let me see if I have the same. Yeah, let me go back to the project. Because I'm not sure if the geometric deep learning thing is gonna be the best. And the issue with these things is obviously that the libraries are huge and it's very hard to understand how everything is connected. So I'm concerned about starting off with the wrong one and spending a bunch of time. Obviously, I don't lose the time because I'm still learning, but it would be better if I was able to figure out what is the best one to use for what I'm trying to do. As I'm probably, the goal is going to be to modify them eventually. So I need to understand the source code. Ah, yeah, so now it shows this because it's everything inside of or outside of the fractal. Yeah, so I guess it is working. It's just a matter of figuring out what is the range of the boundaries. And then, yeah, that's the other issue though. because I have to figure out the range. So how can I test that? And so what I want to do is get multiple different parts of the boundary. Hmm. Thinking maybe, yeah, maybe working backwards is also interesting, where I start with the matrix and then I try to. And the only issue with that, I guess I can use exact numbers based on the, but it still would be hard actually. Because I'm thinking about starting with the matrix and then from the matrix trying to get the points. But I think that's really hard to do. I'm gonna try different numbers while I think about this. That's the difficult thing. There's multiple different ways to go about this, and it's really hard to think about what is the best way to go about thinking and what exactly what I'm trying to do. I'm gonna put more 30 more minutes and then I think I'll stop. The thing is that there's no way about it. I have to just sit quietly and think about what I wanna do. The only way to, because I'm not sure if the things that I'm trying to do make sense or not, or I'm just tripping. But I think it makes sense. I'm trying to figure out a way that I can get the matrix exactly at the boundary each time. So I have to do something with the ranges, obviously, and something with the matrices. I'm trying to think about how to make the condition because, yeah, I know that I could make something that's the first elements in the right of the matrix are 0 or are 1 because they are inside, and the other ones are 0. And that would make it so that the ranges, so that the matrix is always in the boundary. But the question is how to do that because I get the values from calling the function. So let me think about this one. I guess I can manipulate here. Yeah, but then I can't change there. I have to change here every time. Maybe I can create a Boolean value, and then if I pass the value, then I change it. If not, I don't. So here, for example, I could do it uh, by index. Hmm. The issue is that I'm still dependent on the C value, what I pass to the C. So size X and size Y. Because if I pass size X 5 and size Y 10, then none of them are gonna be inside, are gonna be the boundary regardless. So it doesn't make sense. If I put if statements here to check if this number is equal or greater than 0. Another interesting idea, now that I think about it, is using a Fourier transform to determine the complex number. That way you get a frequency of values and I translate that into the matrix. Yeah, but then it's not a grid anymore. That's the thing. I guess instead of using the lim space, I can use a Fourier transform as well. That should be interesting to see what would happen with the matrix. Because the tough thing to think about is what exactly, in the context of what I'm trying to do, if by changing the ranges, I'm gonna, because you're changing the dimensionality or the way that you're analyzing the thing. So if I do a Fourier transform, it's gonna be like a wave instead of so the patterns in the matrix are gonna be different. So the nature of the fractal is gonna be different through the lens of the matrix, of the values of the matrix, which is gonna change the visualization and it's gonna change what I'm trying to do. So if I don't analyze in a continuous range, then I lose the matrix. But in the other hand, I still have the I still have some sort of connection with the fractal, the Mandelbrot fractal, because of this function that is getting the points in the fractal. So the connection is still there, but it's just the matrix, the relationship of the connection with the matrix that changes, and that's hard to think about. In that circumstance, what gets preserved about the fractal? I guess I still have the points. The points are gonna be. It's just a different visualization of the points. but I don't think it changes much to what I want to do. Yeah, so let me think about how to get the boundary. And maybe here I incorporate AI or machine learning, but I feel like that's not necessary, maybe. The values inside of the values on the boundaries of the matrix have to be 0 and 1. The 0 in the left and 1 in the right. So the matrix has to be a gradient from 0 to 1, the values. So how can I train an AI to, or a machine learning algorithm to make the values in the matrix to be a gradient of 0 and 1? I think that's the question. And then instead of doing the loop, I would have to do something different to get the values of the complex number. Yeah, that's the difficult thing to think about. It's like every cell in the matrix is a weight, and the bias is the complex number, maybe? No, the complex number is the weight, actually, of each cell. And what is the cost function? I guess I can use any cost function that I want. It's just about getting to the values that I want. I think I'll do this in another file because I don't want to mess this one up. I'm gonna create another file here, and then I'm gonna start from scratch. And I know I can use Git, but I I don't feel like doing that. I'm just gonna erase this stuff from this one. So instead of doing these two loops here, what can I do? I think I can do for I range matrix. And then here I put ij. I can do this to change the values. But then what are going to be the values of the complex number? Because the problem is not the complex number itself that changes the value of the cell. It has to be the value of this function, which is impossible to predict before putting the complex number there. That's why I think I'm struggling with this. Because I don't want to change the recursive function. That's gonna complicate things a lot, I think. So the question is, which complex numbers are going to produce values between 0 and 1 in this function? So I have the inputs, C, outputs, the function, results, Mandelbrot, and then I have the matrix, which are the weights. So what I'm trying to optimize is the distribution of weights in the matrix. I have to go from 0 to 1. It feels like it's supposed to be simple, but I don't know how to do it. The thing is because I don't necessarily want to be 0 to 1. I want it to be something that is converges towards the boundary, which is harder, I think. I think maybe I can use a Fourier transform here to make an if statement or create something that has a frequency that changes the complex number based on the frequency. And then I make an if statement depending on whether or not this number is. Yeah, but then I would have to input the number, that's the problem. Because I would have to know. Oh, but this is always going to be deviate from 0 to 1, I think. Yeah, but then it's still the range from the frequency is still arbitrary because I can decide whatever range I want. It's not something that is gonna, because if I put the wrong range, then it's never gonna converge towards getting the results. It has to be something that naturally converges. I think it's not that hard, but I just don't. I have to study the documentation first. I have to decide which one I'm gonna use, and then I have to study the documentation. But I think what I have to do is use the matrix as uh, not as a cost function, but have a cost function because the values are gonna be that I'm trying to get are an approximation of 0, but it is not 0.5 actually. Because I wanna get the boundary. I wanna go deep into the boundary. So the question is what values will increase or go deeper into the boundary. And then I can train a neural network to do stochastic gradient descent to based on I think whatever cost function to approximate these values. So I find which complex values are gonna go closer and closer to the boundary. Oh, the values are always between 0 and 1. Actually, it depends on the weight that I put there, which is gonna be, and I also can change this number as well. That's the other thing that I can change. I can put infinity here in Python. I don't think it's necessary for now. Maybe later I'll put that. I think actually to make it easier, I can do from 0 to 100 here, and then I just increase by 1. But it has to be... Oh, that makes sense actually. Probably easier. I'm gonna do 0. So if it's 0, it's inside. If it's 100, or based on the iterations here, then it's outside. And I'm passing 50 actually. 50 iterations. Let me pass 100. So actually, it has to be a function of the max iteration. But the thing that I'm struggling to think about is that I don't want most of the cells should be 50, because even though that would be in the boundary, I don't think that increases the resolution a lot. Like, it's gonna get in the boundary, but the question is, how do I go deeper inside of the boundary? I guess it's the range that determines that, not the weights. Because the weights are the value of the cells. The range is the space that I'm searching for. So the range is the thing that determines. Yeah, the range is the thing that determines the value. Yeah, but that's the question, I think, because what would be the range that has the highest resolution, let's say? That's the question. Because the range is directly connected to the values of the matrix. So if I find, but what would be what would the distribution of values in the matrix be equivalent to the highest resolution of the ranges? To find the deeper, uh, the deeper structures of the fractal, let's say. Because in these animations that they do, I think that's what they do. They're going deeper into the boundary, and the boundary is infinite. But then that's what's difficult, because since the matrix is finite, and you can always go deeper inside of the value, so the ranges are changing, but the matrix is fluctuating in value depending on whether or not. Um, but it's always the same thing, right? Because it's always the same size. Yeah, but there should be a correlation there, and I think it's gonna be, because that's what the fractal means. I think that's what it means. Is that even though the scope, the matrix doesn't change, the values fluctuate in a similar way. the resolution is changing based on the range. Hmm. So there must be a frequency of values in the matrix that determine different portions of the ranges. If that makes sense. Yes, that's the thing that I think is not that hard, but is I'm struggling to frame this in a way that I can use something or can because I don't think it's worth trying to build things or because writing the things is pretty easy. It's just you create a model and stuff because you have all the libraries and people did the code already. So that's not the hard part, I think. The hard part is figuring out how to frame this in the best way possible, I think, to what I'm trying to do. And I think it is the way that I'm thinking about now, which is the matrix is like a sine or cosine wave, where depending on the frequency of the values, the change in the values of the matrix, it changes the scale that you're observing the fractal. But the fractal, and that's why it's a fractal, because it's always going to be the same distribution of values, but depending on which range you change the values of the matrix, instead of depending on this formula here. That makes sense. Yeah, if there was a way to populate the matrix first and then see the make the function to see to get the values that would be equal to that. I guess I can do a while loop, but maybe that would be it would take a long time. I can populate the matrix based on values. Yeah, but then that's the thing because it's still arbitrary values. I'm thinking about the matrix and then I change the value of the matrix based on whatever function. Like I'm moving through space in the matrix, and then as you're moving the values in the matrix, it moves the values in the fractal because they are connected, obviously. So you input the matrix values into the formula to see if they are fractal or not. So basically the other way around. I think what I'm gonna do to start, just so I don't spend a bunch of time sitting here, I'm gonna do, I'm gonna make this equal to a value instead. Let's see, weights or W. Let me see how to do a Fourier transform. Because the issue is that they all have to be connected. That's the problem. I'm thinking about making this equal to a value, and then I capture the values that are from 0 to 1, or whatever the weights I put are 0 to 100. And then only if they are on that range, I change the value of the matrix based on that. But the issue is that I want to get a gradient. That's the problem. So maybe I should do this outside of the function. I should do a while loop outside, and then I make the range based on the while loop. Yeah, I think what I have to do is search how to. I have the input and the output here, so I have to search how to train a neural network to optimize this for 50. This value for 50. So this is the input, the complex numbers, and this is 50. Does that make sense, or? I'm not sure if a neural network is necessary. And pretty much what I want to do is get in the middle the values that take 50 iterations, which is half, to deviate towards infinity, because that means I'm close to the boundary. Or maybe even closer to 0 I can get. And then from that point, I create the ranges. But it's gonna be a limit, I think. And the closest to 0, the better, I think. But not 0, because 0 is a part of the thing. So maybe it's just a matter of minimizing this to 0. But then there's still the question of what's the relationship between the two. Because I can make an if statement that says that if this is greater than 1, then keep going and change the value of C. But then how does C, which values should test? That's the question. Because I don't want 0. I want the closest to 0 as possible, I think. I think I'll stop here. I'll think about this more off stream. Because it's hard to frame or to think about exactly what I know. I have the general idea of what I want to do, like I talked about a lot of times. I want to find the relationship between, because essentially I view the matrix as this window, let's say, and then the window is taking snapshots of the fractals. So there's the relationship between the weights of the window. Maybe it's convolutional neural networks that I have to look into. That's probably what makes more sense. Because that's basically what I'm doing. I'm analyzing the weights of the pixels. So it's like I'm taking a picture and then analyzing. So yeah, convolutional is probably the right one. And then this image has the correlation with the fractal. And then I'm trying to figure out how to go deep inside the boundary so I can capture multiple different snapshots of the fractal. And then once I have multiple different snapshots of the fractal, I want to see if I can find a relationship between that and a neural network. So I can train a neural network to identify fractal patterns inside of images. That's what I want to do. And then once I have that, then I can train on other fractals. And then once I have that, I can get data and then see if it makes sense or try to find the correlations between data and the fractal patterns. And maybe create a neural network that identifies fractal patterns inside of images or data sets. Yeah, I think that's the goal. But I'll continue this another time. No, not sure when, but I'm probably gonna do this next time I'm streaming. So yeah, see you then.